class, we are on chapter 3. Yay! We finished chapter 1 and 2, so we have 3, 4, 5, and 6, some of the parts. So, chapter 3, we are going to see if we can take a derivative using all the formulas. So, before we took a rate of change, very long procedure, and now you can use the formula that I'm going to introduce. So by this section, we are going to do 1 or 2 at a time. So this one and the next section will be a little bit easy, but after that it's gonna get a little bit harder with algebra. So keep practice all the way to the end, and then it's gonna be very tedious. But for me, I really like derivative. I thought that it was a kind of playing game, so I did it a lot when I was young. So I wanted to also keep playing until you get the right answer, and look at it, it's gonna build up. So keep practice with me. So first, today we're gonna do power rule and then polynomial derivative, which we already been studying before. So it's gonna be very short, nice video if I don't talk too much. So before one, we'll look at the slope of those given functions, and this one let's call it the slope m. And then what happened, my function multiplied by 3, that means my function is going to be stretched vertically 3 times. So if my slope was m, then now it's going to be 3 times steeper than before. It makes sense, right? Also, you remember that when I was taking derivative using rate of change, I said I don't want to do such a long calculation, or when we were taking derivative with, I don't want to use those long calculations, so I pull out some factors in front and then I just took the derivative inside and then multiplied. That's actually the rule that I was applying right here. So if you have a derivative, also it's going to work same as a transformation. If we stretch 3 times, then you are going to have 3 times bigger slope. If they divide by 2, then your slope is going to be less steeper by over 2. And if you multiply by -2 on your original function, 2 will make stretching twice, negative will make upside down, so your graph is going to look like that way. Then that will influence the same thing as your slope. That's going to be -2m, which means if this one was 1, by stretching 3 times, your slope has to be 3, and by compressed by 2, that's going to be 1 over 2, and then this one is a flip, and then stretching by 2 is going to be -2 as your slope. So I want you to understand the factor in front of this slope also you can regard as just a number multiplying, so you can apply after the derivative or before the derivative. Okay, so if you look at the next paper, we are going to study about the derivative properties, and then when we can do what are the rules. Some are very easy, some are not, but just keep studying with me. Now let's look at what kind of rules we have. So before we do, let's look at this fancy notation. That means derivative of my function respect to x, I'm taking derivative. So I'm only taking x value as a derivative. So if I have a constant, like 0, what will be the derivative? So if I have a number like a 5, if I take a derivative, that becomes 0. What is the derivative of 0? Then 0 again, right? You can see from the graph, flat. Then next one, let's do in-class activities here. So if you look at this one, what would that be? That will be also 0. Fancy way, you can write df over dx. Output, input, like a rise over run, okay? Then that is going to be 0. Same meaning, when you have a variable x, y, z like that, then we use this notation. If you have a function g, h, j, then we like to use this notation. It will pop up later on chapter 3. So keep building your thinking and don't skip it, because it's gonna be regretting later. Then power function. What is the derivative of power function? We actually have studied with the variable first. So let's look at this one if you can get it. If I take the derivative, then it's going to be 6 comes to the front and then x to the 5th power, right? So if you apply that rule, what happened if I had x to the n? I'm gonna bring n to the front and then lower 1 power down. That's what they're saying. Hope that you understand the meaning here. So I want you to do next one. I want you to do hard one. If it's a negative 6, what would that be? Okay. Try quickly. I got negative 6 x to the negative 7. It's a little confusing, but keep subtracting 1. That's what I'm doing. Negative 6 over x to the 7 power. That's how I want you to write it. And next one, your book may accept the answer with negative or this one. So when you do homework, just check and then careful. I will try to make attempt a little bit bigger depending on questions. And constant multiple rules. Okay, before I'm gonna explain this rule, let's just look at here. If I wanna take a derivative, make sure I don't use equal sign. I'm taking derivative, they're not the same. I can pull out 3. I can ignore it, take a derivative of my x-related function, which is 4x cubed, and then after that, I can multiply 12x cubed as my answer. What does that mean? If I have factor in front of my function, I can pull out and take a derivative. After that, you can multiply. Now it makes sense to you, right? So I want to try next one. What will be rule? This one is the same thing. You can just take the negative out, take a derivative which is 1. So my answer, negative 1. Sometimes the easy one is confusing, right? Number 4. So we also seen this one. Can we take a derivative? I will do fancy notation again. Output f function, input x function, so df over dx. Then take a derivative separately. 4x cubed minus, we talked about it, 6 you can ignore and then take a derivative of x squared makes 2x. And what is the derivative of a constant? That's 0 because there's no x, so you just going to be 0. Then simplify 4x cubed minus 12x. That's going to be my derivative function. Then what are they saying? If you have a subtraction addition, you can take a derivative separately. If you have addition, you can take a derivative separately. If you have a subtraction, you can take a subtraction separately. So basically, they are having similar rule as an algebra. But remember, you can add and you can subtract. Then you can have a factor, pull it out. But we haven't seen multiplying or division yet, right? So wait for that one. That's going to be a little bit headache if it's new for you. Now here's the class activities. So I want you to, I didn't show you yet, right? So you try it and then compare answer with me. So how did it go? First step wasn't too bad, right? And then organizing requires a little bit more time. So I want you to do carefully, and then this one you have to do many times that just to get familiar mentally. Eventually you're gonna get from here to here, okay, here to here, here's just right away here. Some people actually train, a lot of people I see, they can actually do it. You can do it too, so keep playing. Chapter 3 is a serious game, so keep doing more, you will get faster, you will do so much better too. So I know that up to writing here wasn't too bad, right? And then what I did was bring power down and then subtract 1. So careful, just subtracting. Don't use a calculator when you use subtract. And after that, I know that this is going to be denominator square root of x. And the denominator x to the 5. And then cube root of x to the 4th power. And then cube root x to the square. And then square root x cubed. So you see that how far I simplify. And hopefully you can get there too. Okay. Yeah, seriously, when you do homework, and I want you to go this all the way, but when you do homework with Wiley Plus, let me know which one they take the answer. Okay.
okay?
Okay, let's look at our main dish. So when I look at this one, what's happened here is, look at the power carefully. It will be easier to changing everything to power function. So I'm gonna rewrite again. 5x to the what power? 1 over 2. This is gonna be 1 over 5. X to the 5th plus x to the 2 over 3 plus 3 to the x square root of 2 plus max. Okay, so I want to take a derivative, and the reason I changed the all power function because I can apply the power rule of the derivative. So derivative, do it carefully with me. 5 times 1 over 2 x to the negative 1 over 2 minus 1 over 5. I just doing circles and then leaving factors out. 50x to the 49th power plus 2 over 3 x to the minus 1. That will be negative 1/3 plus 3 out, and then wow, that big. What should I do? Square root of 2 minus 1, right? That's only algebra way we can do it. Plus, what is it? Max. It's like max, right? So look as if we had 5x, what was the answer? So 5, right? So what will be the answer here? It's tricky, I put it there. So, am I happy with this answer? No, I want you to still simplify all the factors and negative power, organize it. So my final answer, 5 over 2x to the square root, right? Now you see that will be square root, and 550 minus 10 x to the 49 plus 2 over 3, again denominator with cube root, plus 3x square root of 2 minus 1 plus ma. That's my answer. That was a main dish. So now I want you to do in-class activities carefully and then compare the answer with me. Do you see my answer? And hope that it went smoothly. So when you see first one, I subtract 1 from pi. So that's what I got. Next one, I changed to power rule, power function, and then took the negative 1 and then I rewrote it as a denominator. And same way, I rewrite it as a power function, subtract 1 makes negative 5 over 4. So from here, you can simplify it one more time as x pull out, first root of 1x stays. This one probably the better answer. And then this one turned out to be x to the negative 0.9. So I put the denominator part. 3y do not have any x, so you can regard as a constant. So if it's take derivative, it becomes 0. Since there's not x, y you can regard as a constant. Also, like 5 taking derivative 0, y taking derivative is 0. Because we are taking derivative respect to x. So you just need to focus on x value. So 5 becomes also 0. And then fox is going to be without x, fo is going to be remained. So that's it. And I hope that you got the correct answer 4 after we built up our thinking of the power function. So let's continue our main dish number 2. This time, find the second derivative of function, and then we are going to find what the sign of the second derivative function is. So if you look at the graph, I think it's probably nice to analyze it. So I will just put it our graph here. That's going to be this shape. Next one will be this shape. You see that a lot of graph repeats, right? And then this graph is going to be your activity, so you do it. And next one, we want to find the second derivative. That means we have to find the first derivative. So first derivative will be 2x, everybody okay? And then second derivative will be just 2. So I'm going to actually graph right here. My second derivative is 2. Then they said interpret its sign. What does that mean? I want to interpret their sign. when you look at the second derivative, what does the number show? Is it positive or negative? Do you see that it's a positive? Why? Because I showed it algebraically, but another thing you see is, what does concavity say? Concave up means my second derivative has to be positive, which means above the x-axis. Backwards, if my second derivative is above the x-axis, that means my concavity has to be open up. Let's do one more time. So first derivative will be negative 2x to the negative 3. If I rewrite it, negative 2 over x to the cube. Do you guys remember this shape? Okay, but now we have to take a derivative one more time. So now look at here. What will be easier to take next derivative? This will be reusing it, right? But it's easier to understand that way, so what function form is. So negative 2, and then I have to bring negative 3, x to the negative 4, the second derivative, I get 6, x to the 6 over x to the 4th power. Do I know this graph? Yeah, I know the rough shape. Rough shape of this graph will be look like a x squared, but it's steeper, right? Like that. And then 6 will increase by 6. So the point here is going to be 1, 6. You can plug in 2. Then let's talk about what does the function say. So look at here. Is this a concave up or down, class? Original function is concave up. Then my function of the second derivative has to be above the x-axis. Same thing, if my function is concave up, this is concave up, then also second derivative will be above the x-axis. That's what they're talking about. So what is the sign? What is the sign? Whole this time, do you see that my sign is whole time positive? That means all my graph will be concave up. Look at here, do you see that this number is already positive? So it's going to be concave up. Now, I want you to try C. Okay, pause it and then quickly try. Okay, so what I got, I just graphed it and then algebraically I found first derivative, second derivative. Now let's talk about second derivative. Here says 6x, look at my graph. Can you tell me concavity, is this up or down? That's a down. That means my function second derivative in here has to be minus. Then right side, when you see, do you say concave up? That means my function has to be, second derivative has to be positive side. So now compared to my second derivative, if I graph 6x, I'm going to have this function, and now here's a 0. So I see that from 0, my function is a positive, so concave up, here negative, concave down. So I can see the shape of the graph by looking at second derivative. Then now I want to talk about this one briefly. Do you see that my function 3x squared, is this function always positive or negative? Always positive. My first derivative function says always positive. What does that mean? My function, the speed will be always positive. That means it's going to be increasing, right? Increasing function. So look at, is my function increasing everywhere? Yeah. That's why your second derivative function is always a positive. That's pretty cool, right? Okay, so I want you to continue dessert. As you see, dessert part, you have done this one before with me on 2.5. So I want you to do one more time. It's exactly same question. So do one more time without me, and then can you check the answer from previous paper that you all have them. Also try to make a binder. It's going to be lots of paper coming and lots of practice work coming. So make a binder so that you can organize all those work or save it nicely. And compare this one with the answer. Do one more time. Also, if you look at, I put another in-class activities, which is 2.3, because those are the very big main idea in calculus. So I want you to also continue this one, and then the answer is shown 2.3. So compare the answer. Now, from now on, you're done with rate of change. Probably I may ask a couple of times, and the book will ask some definition way of solving it, but you can use from now on all these shortcuts. Okay? Yeah, so your dessert is actually in-class activities that we have learned, so that I don't want you to forget those important material in calculus. And then thank you so much for listening 3.1, and I will see you 3.2. Good job.